Hi there, everyone. Thanks for joining us for today's Safety and Health webcast, sponsored by Hytera. We will start the presentation shortly. We're going to give our audience just a minute to settle in today. Thank you. Once again, folks, thank you for being with us today on today's webinar. We're going to start the presentation shortly. Hello, everyone, and welcome to today's Safety and Health Magazine webcast, the complete guide to radio communications for safety professionals, sponsored by Hytera. My name is Barry Botino. I'm an associate editor at Safety and Health and a co host of our On the Safe Side podcast. I'll be your moderator for today's event. Before we get started, I'd like to share a few housekeeping items with everyone. First, the views of today's speakers and organization are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Any mention of a commercial enterprise, product, or publication does not mean the council or the magazine endorses those items. If you have a question at any time during today's event, you can engage with us by using the Q&A button located at the bottom of your screen. Just type in your question and tap the send button. We'll get to those questions during the Q&A session after the presentation. You'll also be asked to complete a brief evaluation survey after the event, but I'll tell you more about that a little bit later. Finally, this webcast will be archived. If you want to view this presentation or any of our past webcasts, please go to safetyandhealthmagazine.com/events. You may also receive a link in our post-event email. Now let's introduce our speakers. Joining us today are Julianne Baker and Ty Estes.
Hi.
Julianne serves as the push-to-talk over cellular product manager for Hytera US and is responsible for product planning and marketing, gathering and prioritizing product and customer requirements, along with analyzing and understanding how the product line meets the needs of a variety of vertical markets. Ty is Hytera's marketing director and has more than 20 years of experience in marketing wireless communications and network technologies. He has served as the chair of Telecommunications Trade Association committees and authored several technical papers. With that, we welcome you both, Julianne and Ty, and whenever you're ready, Ty, please take it away.
Will do. Thank you very much. So we're going to cover a lot of ground today, so I'm going to jump right in. So as we know, it's probably why you're attending today, is that we know that radios are critical in safety management. They're used for real-time emergency response, for instantly reporting incidents and hazards, coordinating medical responses, and evacuation procedures. They're used for routine checks and routine check procedures. With lone worker and field personnel, we're entering confined spaces, verifying safety protocols, and for quick communication during safety audits or walkthroughs with inspectors. They're used for team coordination and workflow management to communicate handover details and updates during shift changes, task assignments, and hazard updates. Radios are used for live communication while conducting emergency drills and training exercises. They're also used for operational oversight in high-risk areas, like confined spaces and high places, hazmat zones, and preventing accidents involving vehicles, machinery, and falling objects in construction sites. Some two-way radio systems provide incident documentation support by recording communications with timestamps for post-incident reviews and reconstructing event timelines during investigations, and for interdepartmental communication for integrating with security and facilities teams and coordinating with contractors and visitors. Now, the challenge is that there's a wide variety of radio system available. There's different wireless technologies and protocols, different types of radios and devices that have different safety and security features. There's different systems offering varying levels of redundancy and reliability. They support different call capacities and coverage areas, and you get what you pay for. So there's a wide range of costs in radio communications. So this presentation will review and compare the different types of radio systems and technologies so that you can choose the right communication systems for your organization. And let's jump right in. All right. So what we're going to cover today is part one. We're going to go over LMR and DMR radios, and these are narrowband radios that use licensed frequencies. We're going to talk about the standards, the DMR standards, different types of DMR radios, how to migrate from analog to digital, and then we'll cover a whole bunch of systems like repeaters and dispatching and IP connect and trunking systems. Then I'm going to hand it over to Julianne, who's going to talk about all things push-to-talk over cellular, and then I'm going to wrap it up with a summary, and we'll do our some polls and a Q&A. LMR narrowband radios use a range of ultra high frequency and very high frequencies that require SEC licenses. Frequency licenses are purchased through radio dealers and frequency brokers, and having a licensed frequency guarantees dedicated frequencies for your system and prevents interference. It can be difficult to acquire some frequencies in large cities and high density urban areas, so there may not be frequency available in these areas. And then this year, LMR licensing will reach its highest level in 5 years, demonstrating consistent and growing demand for LMR systems. Let's take a little look under the hood of LMR radio modern technology. Time division multiple access, or TDMA, and 12.5 megahertz channel spacing are two key technologies that are utilized in digital two-way radios. These technologies provide a range of benefits that improve the performance and reliability, and TDMA allows multiple users to share the same digitized radio frequency by dividing it into time slots. So each radio is assigned a specific time slot in which it can transmit and receive data, and the radio switches between these two time slots rapidly, giving the impression of simultaneous communication. This is highly efficient as it allows two calls on the same radio frequency without causing interference or congestion. And this is a key benefit over analog radios that have one frequency shared by all users. There's another technology called FDMA. This is frequency division multiplexing. This does not have digital time slot, and it uses non-overlapping subchannels in the radio frequency for the call. So it divides the frequencies into smaller slices. FDMA requires more expensive infrastructure due to complex base stations with filtering equipment to filter out all these subchannels, and it uses two radio frequency channels for two talk channels. So it doesn't deliver the call capacity per channel of TDMA. In addition, migrating from analog to FDMA digital can be more challenging. So let's compare the two major LMR radio system standards. NXDN, I would call this a sort of a semi-proprietary protocol. It's developed by Kenwood and ICOM. It's used in many commercial applications. NXDN uses the FDMA, frequency division multiplexing with the non-overlapping subchannels. And because of that, it requires more infrastructure, and it does not deliver the call capacity like TDMA. Also, due to the proprietary technology and dense infrastructure requirements, NXDN radio systems are more expensive than DMR. And DMR is digital mobile radio. This is an open radio industry standard developed by the European Telecommunications Standard Institute, or ETSI, and is promoted worldwide by the DMR Association. DMR is used in professional and mobile radio applications. It's supported by most radio manufacturers. DMR has a high transmit power and fully leverages TDMA technology for the sweet spot in call capacity, data rate, and range. DMR interoperability is very good among different manufacturers. And because DMR is available widely, it's standardized, it is the most cost-effective professional radio system available. I also want to mention two other LMR radio standards, P25 and Tetra. Now, P25 is primarily used by public safety, and this market is controlled by Motorola, with some sold by BK Technologies and Kenwood. It's used primarily in government agencies for interoperability with first responders, fire safety, and police and things like that. Now, Tetra, this is a well-defined standard used mostly in Europe, but a handful of utilities in the US use Tetra. It's a very defined It's a very defined protocol, but it has a very high density of infrastructure. And because of this, both systems, both 225, they have similar technology to DMR, but they are very expensive. So we'll focus on DMR for the first half of this webinar due to the broad availability and interoperability across most manufacturers, the low price and performance, and it also delivers 20% longer battery life than NXDN. So as I mentioned, DMR is a widely deployed radio standard, and it uses the TDMA technology to double the call capacity per channel. And this results in a more efficient use of the radio frequency spectrum, which is also a finite resource. Unlike analog systems that are susceptible to interference and background noise, DMR radios provide clear and crisp audio quality even in noisy environments. DMR with TDMA transmits information in short bursts, which conserves the radio's battery power, resulting in a 40% improvement in battery life compared to analog radios. And TDMA with the channel spacing allows for better frequency reuse, which increases the coverage area of the radio system. Now, this industry-wide standards compliance is important because it ensures that all radios and base stations operate on a standard that's common. It enables reliable communications, and it's more effective than a system based on proprietary technologies. It also future-proofs your system because there's not going to be some version that comes out from a proprietary system that you need to upgrade to keep up with. Migrating from analog to digital two-way radios delivers all the benefits of DMR technology. Companies with analog radios can easily and gradually migrate to DMR radios because DMR radios work in both digital mode and analog mode. And this enables a cost-effective migration path without a big one-time and upfront system purchase. So DMR radios can be added over time to an existing analog system. Once they're all replaced, you can switch over to digital, you can add repeaters and grow the system as you want. Professional radios, LMR, including DMR radios, support a variety of call types. One of the benefits of two-way radios is they do instant group calls to predefined groups. So you can select the talk groups on the phone screen or the channel knob, and then call them with a touch of the PTT button. You can also make individual radio-to-radio calls and emergency calls that are broadcast to all users or predefined groups. Many radios have emergency call buttons for easy and instant emergency calling. Radios can also send pre-programmed text messages for commonly used text communications, or you can freeform text with radios that have keypads and touchscreens. And by using a dispatch application, a dispatcher to central location can handle a lot of calls coming in, and individual and group calls, and even see user locations with GPS-enabled radios. So as you can see, digital two-way radios provide a wide variety of communication options for your business. Now let's drill into these group calls. Now here's a diagram that shows how different talk groups can be organized. Most companies use several call groups that are set up based on emergency all-call emergency calls, or departments like transportation, operations, safety and compliance, and security. And also note that users can belong to multiple talk groups as shown in the overlapping areas. And considering and planning how you'll organize your call groups is an important part of the successful implementation of a radio system. Using call groups minimizes distractions by ensuring that only the relevant parties are involved in the conversation. Now here's a diagram of how call groups can be used across a large manufacturing company with multiple locations and many users. You can use similar call groups for each location as I showed in the previous slide. And with the right DMR radio system infrastructure that enables the range and capacity, which I'll cover in the coming slides, you can have call groups for different locations. These are called zones. And you can have enterprise-wide call groups for emergencies like natural disasters. Call groups can also overlap multiple departments. So a call group may include all the safety managers at 2 or more locations. So DMR handheld radios. These include all of the DMR standard benefits. They include digital noise cancellation. The voice codecs are designed to minimize background noise. In addition, some radios include AI-based digital noise cancellation, and this is a technology that learns the human voice in real time and filters out the background noise. They have a high transmit power for farther range. They're durable with the IP68 and mil standard rugged, meaning that they're waterproof, dustproof, and impact resistance. They're also available in intrinsically safe models for using in facilities where explosive gas and dust are present because they're designed to not generate any sparks, so they're safe to use in those areas. They feature lithium polymer batteries. These are the latest battery technology. They last a long time and they're really lightweight and compact, adding to that lightweight device. I'm sure a lot of you have carried these heavy brick radios around. The modern DMR radios are very lightweight and easy to use. They operate on multiple systems, which I'll cover coming up, and they include advanced features like GPS location tracking, Bluetooth for wireless accessories, and encryption for private and secure calling. And they support a wide variety of worker safety features like man down and lone worker. On DMR mobile radios, these also include all the standard DMR benefits. They also have the digital noise cancellation, but they also have a higher transmit power. So a handheld radio would have 4 or 5 watts of transmit power. These mobile radios that you put in a vehicle will have 25 to 50 watts because obviously you're driving around, you've got an antenna on top of the vehicle, you need a farther range. They also support multi-system operation, the different advanced features, worker safety features, and it's important to note that mobile radios with a handset are safe and legal to use while driving. So if you've got employees driving around using cell phones or tablets or handheld devices and talking while driving, that's illegal in most states, a safety hazard and a liability. All right. A lot of companies start out with a few radios and use them for radio-to-radio communications because it's simple and inexpensive. The limitations of radio-to-radio deployments are call capacity and coverage area. A DMR Tier 2 radio system uses repeaters to extend the range of the radio system throughout a large facility or service area. And both DMR and analog radios can be deployed on these Tier 2 systems. A DMR Tier 2 repeater site consists of the DMR repeater, antenna systems, and supporting equipment like power supplies, backup batteries, duplexers that allow the 2 channels to go over the same antenna, dispatch and monitoring systems. And this system is sometimes referred to as a base station. They're also installed by authorized radio system dealers who can configure and install all the necessary system components. The DMR Tier 2 repeater is the heart of the professional DMR radio system. It's responsible for receiving and transmit radio signals over a wide area. So repeaters receive a low-level signals from handheld and mobile DMR radios and then retransmit that information at a higher power level over a greater area. And you can also deploy multiple repeaters in a Tier 2 system for additional channel capacity. So we get asked quite often, what is the range of a DMR repeater system? And unfortunately, the answer is it depends. You're going to hear a lot of people out there saying, oh, they generally do 100 miles or they do, no, that's not true. It's very determinant on a lot of variables. The range of a repeater system, I would say conservatively, just to be safe, so that you're not making promises that can't be met. I would say 30 to 50 miles. And that includes the distance of one radio to the repeater and the distance of the repeater to the other radio. So for example, here we have 5 miles to the repeater plus 30 miles to the other radio equals 35 miles. Now, there are several variables that impact the range of a repeater system and radius. One is the primary thing is obstacles, like buildings, hills, walls, and even trees are the primary determinant of the range of a radio system. UHF and VHF wavelengths go farthest with line of sight, like flat open country or the ocean. Obstacles dramatically shorten the range, especially mountains and thick concrete walls and buildings, and dense buildings can limit the range to just a few hundred feet. Another factor is of the system that affects the range is the antenna, the height and design of the antenna system. The higher the antenna, the fewer obstacles for the radio center, the radio signal, and that's why antennas are typically installed on tops of buildings and mountains. And even the radios themselves can impact the range. The transmit power of the radio, the transmit and receive sensitivity, the antenna gain and attenuation, the technology in the radio will also impact the transmission range. But the bottom line is that a professional DMR system installer and DMR system dealers, these guys are expert in designing and installing systems that will cover the required areas. So they'll come to your place, they'll do a site survey with test equipment and design a system that provides the necessary coverage throughout the facility. And we're going to look into some other DMR systems. First one's called IP Connect. This is a digital interconnect that uses Internet Protocol, or IP, to link multiple repeater sites together, creating a wide area network. The IP network transports the DMR digital data, and because DMR is digital data, it's transparent and agnostic on the network, meaning that any type of network, such as the internet, a VPN, or an Ethernet network, can be used to connect the repeaters in an IP Connect system. It's typically deployed by organizations that have several locations with repeater systems, and they need to communicate between these sites. So, for example, a company may have many facilities, and they require communications between all locations, between the warehouse, the manufacturing system, facilities, and the offices. IP Connect allows users to make calls to different repeater site locations. So in this diagram, a user at site 1 on the left initiates a group call to users at site 2, and the call takes place as if all the users were in the same location. And deploying IP Connect is as simple as upgrading the repeater with an IP Connect network license, doing some repeater programming, and adding a network router to each location. IP Connect systems can link multiple repeaters with up to 255 locations over multiple IP networks by configuring primary and secondary repeaters. And when the coverage of an IP repeater locations overlap, this is a feature called roaming, and this allows the radio to switch between the two sites instantly and automatically. This is typically for mobile radios and trucks that drive between different repeater site locations, and it's like driving in a car with your cell phone and getting continuous connectivity from cell site to cell site. And developed exclusively by Hytera, the extended pseudo-trunking XPT system. This is based on the DMR Tier 2 conventional standard, and it adds capabilities normally found in high-cost Tier 3 trunking systems, which I'll go into in the coming slides. XPT is designed for organizations that require high-capacity group communications. So, for example, a large company may find that they're getting a lot of busy signals on calls at a specific time of day, and they need a higher group call capacity to make sure those calls get through. So XPT uses a simple network switch to manage a stack of multiple repeaters and to provide more channel capacity and add some other valuable features. And a key advantage of XPT and a differentiation between that and the DMR Tier 3 system is it does this without the use of what's called an FCC FB8 control channel frequency. And this is a frequency that is a special and expensive frequency that must be available all the time, and it provides a management channel for all the repeaters on the network, which is not needed in XPT, and that's why it's deployed quite often to increase group capacity at a very cost-effective way. Multiple XPT systems at different locations can connect over an IP network, just like IP Connect, but with the added trunking functionality to expand the group calling capacity over all the XPT sites. Multiple group calls can be made across the IP networks to the other XPT sites. XPT uses routers to connect each site to the IP network, and with XPT repeaters at each site connected to each other with a layer 2 switch. It is common for overlapping again, so the roaming is a widely used feature. Now, the DMR Tier 3 system, this is the pinnacle of DMR system performance, capacity, range, and security, and cost. These are not cheap systems. DMR Tier 3 is an IP-based digital trunking system. It provides high-capacity individual and group calling, dispatching, high security, and radio management across wide geographic areas. The DMR Tier 3 trunking systems consist of a central controller called the Mobile Switching Office, or MSO, which is shown here. DMR Tier 3 MSO systems include several radio network components, including repeaters, servers, switches, network gateways, and redundant power supplies. The MSO offers mission-critical redundancy with multi-level failback to ensure 100% uptime reliability. The DMR Tier 3 system consists of 3 layers: the application layer, the network layer, and the radio terminal layer, or the radio itself. The application layer includes the dispatching software, network management software for monitoring and configuring the radio network, and call logging and reporting systems. At the network layer, all the radio sites connect to the MSO, which provides the routing functions, the gateways to telephones, networks, and other systems, as well as managing the trunking of all calls across the base station controller units at each repeater site, and a wide area IP network that connects all the different pieces together. And DMR Tier 3 systems use this FB8 control channel as a management channel for the entire network. And then the radio terminal layer includes a handheld and mobile radios. And because DMR is an established industry standard, any DMR Tier 3 compliant radio from any manufacturer can be deployed on the system. And there's another network, it's based on Tier 3 technology, and this is called an SMR network, or a specialized mobile radio network. And this is a wide area network that's called an SMR, and these are often built by large radio dealers and system operators using DMR Tier 3 systems. These systems use multiple antenna towers with different frequencies, and the DMR radios, they can automatically go across the coverage area and switch from one repeater and frequency to another through that roaming. This is through a process called handover. And so these builders of these networks spend a lot of money on FCC licenses, on infrastructure. So they're kind of like a mobile communications operator that leases access to their network to different companies. And there are actually some large companies that own their own SMR networks, but they're typically built and owned by these private radio network operators. And these are networks that can cover cities, metro areas, multiple counties, and even entire states. And radio networks operators lease the radio system and rent the radios to companies like manufacturing companies, school districts, security companies with patrols, delivery companies, any company that needs wide area coverage. They can basically rent access and devices from an SMR network operator. Dispatching systems. So professional dispatching systems are also often used with wide area DMR systems like IP Connect or XPT. They can be standard install software applications or client server applications. They enable instant group calling with high group capacity from a central location. And they can provide location tracking with GPS-enabled radios. And this is often used with people operating fleets. They can also support video applications and enable connectivity to PBXs for phone calls. And Julianne will go into some more detail on the dispatching systems in her POC section. So this ends my section on DMR. A summary, we went over the DMR standard and how TDMA and 12.5 megahertz channel spacing doubles call capacity and adds a lot of benefits like extended battery life and clear audio over longer ranges. You get a simple migration path from analog to digital. You can do it gradually over time. There, you can get handheld and mobile radios for DMR systems. We looked at how repeaters expand the range and capacity for a single facility. We saw how IP Connect can expand that range by connecting multiple repeater sites together over IP networks. And then we looked at the different trunking systems like XPT, DMR Tier 3, and SMR networks that expand the range by connecting multiple locations, increasing the individual and group calling capacity. And with that, I'm going to hand it over to Julianne, who's going to let us know all about push-to-talk over cellular.
Thank you, Ty. In my section, I'm going to cover how does POC work, what are the benefits of POC, the different type of POC devices you can purchase or lease. I'm going to spend some time on the dispatching and then also talk about push talk over cellular for large enterprises, as well as adding POC to the existing systems that Ty talked about. So prior to POC, business communication was dominated by two-way radios on peer-to-peer and local radio networks. Those are the radios and systems that Ty just covered. The concept of push-to-talk over cellular was introduced by Nextel in 1987 as an alternative to these two-way radios. Nextel revolutionized business communication when it started to pass small voice packet from radios across their IDEN network. Nextel's IDEN network offered a then very unique push-to-talk walkie-talkie feature in addition to direct dial voice calls. At its peak in 2005, Nextel had over 20 million subscribers in the United States. Eventually, Nextel was acquired by Sprint, and in 2013, Sprint decommissioned the Nextel IDEN network because it couldn't support modern LTE data and bandwidth requirements. The good news is, though, that Nextel laid the foundation for modern POC innovation and acceptance. Today, push-to-talk over cellular uses the modern LTE cellular infrastructure of mobile network operators to provide nationwide coverage with high capacity for voice, video, and data applications, along with unlimited call groups. So how does POC work? Well, you're probably familiar with voice over IP or VoIP systems that use IP networking to make voice calls. Similar to VoIP, POC is sometimes referred to as RoIP or radio over IP, and it makes similar IP-based calls also using the internet. POC devices access cloud-based POC services via the internet for voice and video calling. POC radios are basically Internet of Things or IoT devices that access the internet for data communications. An app on the POC device provides simple and convenient access to the POC server on the internet cloud for that wide area radio communications. The POC cloud server manages all the calls and the programming of the radio services. The result is access to existing and reliable cellular networks that require no maintenance or operational expenses from the end user. So POC devices can access the internet cloud through a POC server through the existing cellular infrastructure of 4G, 5G, and LTE cellular networks using a data SIM card similar to those used in cell phones. Gateway routers provide connectivity between the LTE networks and the POC servers. The web-based dispatch applications also access the POC cloud server through the internet. And you can see how that is diagrammed out there. A SIM card from mobile network operators can be used in POC devices. Here are two examples of the nationwide coverage provided by two of the major mobile carriers. As you can see, the coverage is not 100%, but it is very broad and it's very reliable. Next slide. Next slide, please. POC devices also support Wi-Fi connectivity and access through the Internet Cloud POC server using Wi-Fi networks that are connected to the internet, typically with a network router. This enables POC devices to utilize Wi-Fi access exclusively if the users remain at the facility, and for that use cases, there are no SIM cards required. If users move about remote locations or are traveling, then the SIM cards are added. POC devices can seamlessly switch between the Wi-Fi and cellular LTE networks. It's important to note that having a solid and reliable Wi-Fi network throughout the facility or site is critical for a good POC user experience. The best way to ensure you have proper coverage is to perform a Wi-Fi coverage verification test using an application such as NetSpot. As part of the coverage test, a reliability and throughput tests are also done to ensure that not only do you have good RF coverage, but you also have a large enough internet data pipe to the POC server. There are a lot of great benefits of using POC. Let's run through some of the key points. First, and very importantly, is the nationwide wide area LTE network coverage. This is a really great feature for large companies with many locations, mobile service fleets, and construction companies with changing work sites over a large area, or security companies that move between facilities. There's high bandwidth and virtually unlimited call groups. There's also no infrastructure or system maintenance costs. POC does not require FCC frequency licenses like traditional UHF and VHF two-way radio systems. Frequency licenses are expensive, and there may not even be any frequency spectrum available in densely populated urban areas. POC devices can typically be used right out of the box. POC systems also support a wide variety of calling options like Ty mentioned. POC systems can also provide a secure and private communication by using end-to-end digital encryption, featuring ARC4 and AES 256 or 128 encryption algorithms to encrypt digital voice and data transmitted over the radio network. Now let's take a closer look at POC devices that I've been talking about. Generally, there are three categories of POC devices: handheld POC radios, POC smart devices or mobile computers, and mobile radios for in-vehicle use. These various form factors can be mixed and matched to meet the need of various roles and requirements within an organization. Many POC devices share similar characteristics and features, at least for high-quality POC devices available on the market. These features include the instant nationwide push-to-talk group and individual calling, supporting the LTE cellular with the SIM card and Wi-Fi connectivity, excellent audio quality with digital noise cancellation, ruggedized to IP67 and IP68 to withstand water and dust, and MIL standard 810 G or H for shock and vibration. Built-in cameras for high-def pictures and videos. They also have that long-life lithium-ion polymer batteries, as mentioned previously. Many have built-in Bluetooth for optional accessory use. Also, there's built-in GPS tracking used with the dispatcher. And of course, there's safety features like external one-touch emergency button for instant alerts. Unlike cell phones, tablets, and handheld devices, the POC mobile radio is a legal and DOT-compliant device for safe communications while driving because it's attached to the vehicle and features a handheld mic with a push-to-talk button that allows eyes to stay on the road when placing or receiving a call. Mobile radios provide loud audio and speaker quality required in noisy vehicles. Optionally, there are highly accurate GPS antennas for precise location tracking for the dispatch application. They are designed with safety with emergency call buttons, speeding, and driver fatigue notifications. And they can also feature built-in Bluetooth for hands-free audio accessories like push-to-talk mics and earpieces. POC handheld radios are purpose-built for professional radio communications. They are available in full-featured models and compact, cost-effective models that can be carried in a pocket or worn around the neck on a lanyard. They may feature LCD display screens for status and call functions. The fully featured models may have a camera for pictures and video calling, full keypads, and flashlights. Most POC radios have a readily accessible emergency call button. You can see that on the top, the orange button. And some feature car kits for safe in-vehicle operations. Speaking of the car kit, here's an example of one that allows you to use a handheld POC radio, like a POC mobile radio, because it's installed in the vehicle and features a palm microphone with a push-to-talk button. The car kit enables you to legally and safely use that handheld radio in the vehicle and also use it outside of the vehicle because you can use that little barrel lock and remove the radio from the mount. Car kits are also available with additional accessories like visor mics, external speakers for clear audio in loud vehicles, and wired push-to-talk buttons. POC smart devices are handheld computers that run Android business apps. So they are essentially a unified business communications device that does mobile computing and communications. If the device is based on an open platform like Android OS, then the device allows you to run modern third-party mobile business applications, helping you get your business done more efficiently. With the familiarity of an Android device, a POC smart device is an excellent platform to handle all of your apps, manage your data, and communicate with your team. These are rugged devices with Gorilla Glass touchscreens and are IP68 and mil standard 810G rated. They feature high-definition camera for pictures and video calls, and some feature a built-in barcode scanner for use in warehouse inventory and security checkpoints. These devices use a lithium-ion polymer battery for long operating charge. And note that they are dedicated POC devices and not cell phones. We often get the question of, why should I use a POC device like this instead of a cell phone? Well, there's really 4 good reasons. POC devices and service plans are much less expensive than smartphones and cellular plans. Number 2, POC devices ensure employees use the devices exclusively for business-related communications and not messaging friends or watching cat videos on TikTok. And the way that you do that is you go in with the manager that Ty talked about, and you can enable or disable certain apps. Instant push-to-talk and individual calls without launching apps, looking at contacts, or waiting for users to answer the phone. This is a POC device, and on the side of the device, you can see there's a push-to-talk button that allows that ready access. POC devices provide features typically not supported on smartphones, the dedicated push-to-talk and one-button emergency button. A key benefit of POC systems is the dispatching applications. These are similar to DMR dispatching applications and can be standard installed software applications or a web browser-based application for easy use and deployment. Dispatching apps enable instant group calling with unlimited group capacity from a central location. They support group voice calls, text messages, and sharing video and pictures. The dispatch applications support group calls that can be made to a predefined list or a dynamic group call made by selecting individuals or a group of users on the map. In addition, a fully featured dispatcher can provide reports on calls, messages, emergency alarms, status, and other items. GPS is an essential tool for managing, scheduling, and tracking remote vehicles. Like DMR radios, POC devices have built-in GPS, and the dispatcher often supports Google Maps. The dispatcher can zoom to any location and find and select users for calling actions and to see GPS travel routes and geofences. On the screen is an example of a GPS tracking route on the map interface. You can see the breadcrumb trail in real time as shown as blue dots with timer stamps. Each dot represents a GPS update that can be a user-defined time interval. The orange area maps out a geofence area that interacts with GPS tracking and enables alarm triggers, say for examples, when vehicles stray from defined territories, or in the case of security, may go into a dangerous situation. So you can tell when your vehicles are going into or out of those predefined geofenced areas. POC systems are an excellent group communication solution for a single facility. But what if you need a system for a large company with hundreds or even thousands of users, multiple facilities, and office locations? POC can be an excellent choice because some manufacturers provide large customer comprehensive software control over the entire POC system, including the servers and radios. This includes control over creating call groups, including local calls and group calls for multiple locations. You could program the radios over the air. This is for call groups, changing radio names, or any other routine maintenance. This console interface allows management of users, easily adding and removing users from the system. It can also generate network traffic reports to better manage the teams and organization of the radios. It also enables privacy encryption levels in addition to the encryption provided by the carriers that comes built into the radios. And you can create a customized branded system to create better brand and logo recognition. POC provides the same group calling capabilities as DMR two-way radio systems that Ty showed earlier to enable those instant group calls to multiple users with the press of a push-to-talk button on a radio or from a dispatching app. This time, instead of a manufacturing company, you could have a security company with corporate offices and multiple job sites. With the POC management system, the customer can control and configure groups across those multiple locations in the company. And with security, the call groups can move to new job sites or locations. And with POC, there's no need for any expensive infrastructure for this wide area radio system infrastructure. So what happens if you have an already existing DMR, LMR, analog, or other trunk systems? Well, a POC bridging system can span between a POC to a DMR two-way radio with an interconnect solution that provides an IP gateway between those of the POC radios and a variety of existing radio systems, including analog, DMR Tier 2, DMR trunking systems, and third-party DMR radio systems. This means you can easily and affordably add wide area POC communications for remote locations or security vehicles to an existing two-way radio system. In this bridging system application diagram, functionality is accomplished with special hardware configuration that interconnects and rebroadcasts communication using a POC mobile radio and the DMR mobile radio. The POC mobile radio provides connectivity to POC radios via the LTE cellular or that Wi-Fi internet access, depending how it's configured. And the DMR mobile radio provides connectivity to DMR analog radios and repeaters via narrowband UHF and VHF frequencies. This bridging system provides a single channel interconnect. If needed, you can add multiple bridges to get additional channels. This is especially useful when companies have an existing radio system at a single location and want to connect to multiple locations or security fleets. So here's a review of the POC section. The big benefit of POC is nationwide communications over cellular and Wi-Fi networks. This is a rapidly growing technology in the radio communications market. It's used by anyone who needs wide area radio communications, rapid deployment, and a low-cost solution. It features flexible calling with group, individual, emergency, and video calls. And there's a wide variety of ruggedized and feature-rich POC devices to meet organizational or business requirements. POC has dispatching applications which provide centralized control and location tracking. And some POC manufacturers provide access to the entire POC system through a management tool, so you can easily manage those large fleets or enterprises. Bridging systems enable adding POC communications to existing radio systems, thereby preserving the investment that someone's already made. So with that, I'll turn it back over to Ty to close with our final section.
Thank you, Julianne. So I'm going to cover a comparison of POC and DMR systems and let you know, we want to go look at a two-way radio system, what to look for and how to evaluate them. So here I'm going to compare a standalone system of IP Connect or DMR trunking to a wide area SMR Tier 3 network operated by a mobile net radio network operator, and then push to talk over cellular. I'm going to compare several things between these three types of systems. First of all, frequencies. With your own system, you're going to need to get FCC spectrum and licenses with an SMR network that's already set up for you, so they're within the SMR network, and then push to talk over cellular using the existing LTE network. System installation. If you're having your own system, you're going to need a DMR system and antenna installations per site and networks to connect them. On the SMR network and push to talk over cellular networks, you're using someone else's infrastructure, so that is not necessary. Now, reliability is going to be the key differentiator between LMR and DMR systems and push to talk over cellular. DMR offers mission-critical reliability and redundancy. They're standalone systems, and they're often the last man standing in natural disasters. POC, on the other side, is based on the reliability of the cellular network, And as we've all seen over the past year or two, we've seen major outages from Verizon, from AT&T. So you're basically relying on the reliability of the LTE network. And in a natural disaster, they're going to give priority on those networks to first responders and to utility companies. They're also based on the reliability of the POC servers themselves. So there's been some major POC providers that have had a lot of outages, completely independent of the LMR, complete of the LTE network. So this is a big differentiator. So if you need 100% guaranteed uptime, you need uptime during natural disasters, then you want to lean towards a DMR or SMR network. Now, security, they're pretty close. I would give a little edge to the DMR networks because they're closed systems. They're highly secure. They have end-to-end encryption. But LTE networks are very secure. And Hytera was the only manufacturer of that matter that offers end-to-end encryption. That means you can encrypt it over the radio to the server to the other radio. So it can be encrypted. So it's pretty close here, but I'd give the nod to DMR. And range, as we saw, it's on your own system. It's based on how many sites you have, how many repeaters, system installation, antennas, and the terrain in which you're using the system. The SMR network range is based on the coverage of the SMR network. And then push to talk over cellular, you have nationwide. Now, we all know that some areas have better coverage than others based on different carriers, but generally you're going to get nationwide coverage out of push to talk over cellular. So you're looking to get a system and you're wondering, okay, how do I qualify this? What am I looking for? So when qualifying radios, it's important to get a live system demonstration. And there are other important things to consider. What are the quality of the radios? Radios, especially POC radios, have a very visible difference in levels of quality and durability. There's POC radios out there that look like consumer toys. Audio quality can be a lot different between different radios, especially in loud environments. So make sure you test the radios in the areas where they're going to be actually used. Also check the warranty period. High quality POC devices have a 2-year warranty, whereas some only provide 6 months of warranty protection. We've had a lot of dealers that have switched away from these manufacturers with 6-month warranty protection because they've seen up to a 15% failure rate in those radios in the months after the expiration of the warranty. And a high quality DMR radios, you want to look for at least a 3-year warranty for those. Are the radios rugged for long life? Make sure they're IP6, IP67, IP68, and mil standard rating for water, dust, and impact protection. How long is the battery life? Look for lithium ion and if even better, lithium polymer batteries to provide up to 24 and even 40 hours of life on a single charge. You don't want radios going dead halfway through a shift when something hits a fan and you need to communicate. Also, does the vendor provide a wide variety of devices and different levels of radios with different features for different applications and users? You might have a general user on staff that just needs a basic radio, push to talk, a channel control knob. You might have some managers that may need more advanced radios and more advanced features. Make sure that you are dealing with a dealer or a manufacturer that giving you a wide variety of radios so that they're tailored to your needs and you're not just getting a one size fits all or just what happens to be in stock. And finally, what is the reliability of the radio system? DMR systems provide legendary reliability, but with POC systems, ask them straight up, have they had recent outages? A POC system should provide highly reliable service with server redundancy. Now, as the Minister of Propaganda for Hytera US, I would be negligent of my job if I didn't throw in some shameless marketing slides. And here's the line of Hytera's H-Series DMR radios that are state-of-the-art in DMR two-way. H-Series handheld and mobile radios feature AI-based noise cancellation, lithium polymer batteries, IP68 mil standard durability. They're the lightest DMR radios available and also provide industry-leading transmission range and an extensive list of advanced features and value. And the important thing here to note is the pricing of 30 to 40% less than our competitors. Hytera is also an industry leader in DMR radio systems that increase coverage area and call capacity. Hytera repeaters, IP Connect, and trunking systems provide industry-leading performance and reliability, and they're installed in thousands of businesses and school districts and organizations across the U.S. Hytera has an entire team of sales engineers that support our dealers with systems quotes, configuration, and staging to ensure smooth deployments. We also offered the Horizon push-to-talk over cellular platform that has a variety of Hytera POC devices that are supported on that platform. It's a subscription-based POC service that supports all Hytera POC devices. It is the most reliable POC service available. It has geo-diverse server redundancy, meaning that we have redundant servers in different locations. So even if an entire data center goes down, your system stays live. Hytera POC radios share all the great features, performance, and durability of our DMR radios. And there are features exclusive to the Horizon platform that include unlimited channels and call groups for free. Other vendors will charge you for those, end-to-end encryption, and the system management for large enterprise. And it also features the Horizon web-based dispatching application, which can be launched and used from any browser on any PC. We also offer, through our dealers, a variety of safety accessories for different users that can include hearing protection and lightweight headsets for hands-free operation, in-ear mics for use with respirators and breathing apparatus, and radio monitoring ear sets. So a wide variety of accessories can be used with POC and DMR radios to ensure your personnel are using them for safety procedures. And with that, we're going to start a couple of poll questions.
It
So you're
looks
going
like
to see
we've got our
okay.
first poll up there, Ty. Thank you for that. I'd like to know, do you have an upcoming radio communications project? And the responses are yes within the next 3 months, within the next 6 months, maybe within the next year, or no upcoming projects. So feel free to click on whichever response suits you the best. We'd like to hear about that.
Get a snapshot of the industry right here and see if you're doing research or looking at a system upgrade.
And just a reminder to folks as you're answering the polls, please feel free to drop your questions in the Q&A. You can click that Q&A button at the bottom of your screen and type in your question and send that to us. We're grateful to hear your questions today.
Okay, so it looks like we have about 60% don't have any upcoming projects. You're just here to learn about your options. We have coming up from the bottom, we have about 20% maybe within the next year, 8% within the next 6 months, and then we have some folks that are actively looking at their options for new radio systems within the next 3 months. So a pretty interesting spread here. Thank you for your replies.
Okay, and now we've jumped over to question 2 here. How many of your employees use radios? And you can respond with 1 to 10, 11 to 50, 51 to 100, 101 to 500, or 501 or more. Go ahead and tap whichever response suits you the best. Excited to see your responses here.
And this will give us an idea of the size of the organizations attending today. We have some larger, some smaller. My guess is going to be pretty evenly distributed. Let's see if I'm right.
All right, and as we wrap up our final poll here, we can go ahead and push those results here.
Yeah, so we have a pretty even spread, about between small to medium. We have some about 14% have 100 to 500, and then looks like a couple of us out there have some large radio organizations with 500 or more. So that's a large network and a lot of radios to manage. So these are companies that are very experienced in using and deploying radio systems.
Absolutely. Well, Ty, thank you for sharing your knowledge with us. We appreciate you and Julianne for giving us the insights you did today. Before we start our Q&A, I want to let everyone know about the evaluation survey that we're asking you to complete. The survey will open in a different screen after this webinar, and your input is really important to us because it does help us to improve our future webcasts. So let's get to some of those questions that have come through so far. And again, feel free to tap that Q&A button if you have a question for us today. First of all, Ty, I want to start with you, and a question is, can you use multiple repeaters in a DMR base station?
Yes, you can. I believe you can use up to 8 at a single location. And as I mentioned, you can connect those together with a layer 2 switch and expand your capacity with an XPT system.
Gotcha. Julianne, the next question I want to send your way is, do the POC radios work on any carrier's mobile wireless plan?
Typically, the POC radio manufacturer could certify their radio on particular carriers. So, in the case of Hytera, we tend to work with AT&T and T-Mobile, and we're looking at expanding to additional carriers.
Excellent. Ty, the next one for you. What kind of accessories are available for the radios that you've discussed today?
In addition to the last slide, which focused on safety accessories that are
Hmm.
available through some of our select dealers, there are charging accessories for handheld radios so that you can charge multiple radios. Basically as a docker, you can just, charge multiple radios at once, which is a convenient way during shifts. You've got wireless mics and earpieces that are available. So there's no wired connection between the radio and the push to talk button or your earpiece. And then for mobile radios, there's external speakers and microphones and things like that make it easier for you to use inside of the vehicle. So there's a wide variety of accessories, audio accessories, charging accessories, et cetera, available for two-way radios to make them more convenient to use.
All right. Julianne, a question has come in from our audience for you. Do your radio systems integrate with any CCTV or ACM systems, such as, I may mess this one up, but is a Vigilan, where an alarm will communicate to the radio and speak the alarm over the radio?
Um, so Hytera is based on open operating systems. So we provide the APIs, which are the communication hooks essentially that allow third-party manufacturers to integrate with our POC radios. So we have worked in the past with other companies. Ty, do you want to answer that on the DMR side?
Yeah, I'd like to expand on it on the POC side too. The uh, the dispatching application that we use does support video communications, and so, and as Julianne mentioned, there's an open API that can be used to integrate these things, and we've been working with um, some cloud-based security video companies. And I think that there's frankly a hole in the market right now because you can see, I can see what's happening at a location. I can see somebody vandalizing something at a certain location. It would be really nice to just click on something within the same interface and call a security patrol that's in the area. So it's possible. There's limited applications available now. You'll see more coming in the future.
Excellent. Thank you for that. The next question I have for you both is from our audience. We have radios to maintain communication during storms and natural disasters. Will POC or DMR work better during these periods of say, poor visibility and sporadic power outages?
I would lean towards DMR.
Okay.
And lean towards DMR on that because they're self-contained systems. A lot of the repeaters that you'll see installed will have backup batteries and UPS systems on them. So if storms are something that you're concerned about and need guaranteed uptime, Yes, I would lean towards a DMR radio system.
Okay, excellent. Thank you for that. Julianne, I wanted to ask you, do you have to use a mobile radio in a vehicle?
So if you would like to be DOT compliant, then you would need to use a mobile radio. And both Ty and I showed images of what those radios would look like. You typically mount them either under the dash or on the headboard of the vehicle. Um, what makes them DOT compliant is the fact that you have the mic, which instantly keys. So as I mentioned, you keep your eyes on the road and it's much safer. And in many states, it's illegal to use a cell phone or a tablet or something in your vehicle for communication. So that's why both on the POC and DMR side, we've designed mobile products ideally suited for vehicles which make you DOT compliant, but then offer some great features like, loud audio, the driver alert notifications. So there's definitely a benefit to using, specifically designed radio for a vehicle.
And
Excellent.
frankly, I'm surprised at how many organizations, including school districts with bus drivers, are using handheld devices for communication. Um, and expanding on what Julianne showed in the presentation, one of our very popular products is that car kit because you can use a handheld radio, lock it into the dash. Now you've got a handheld mic. It's legal to use while driving. And then if you're going to go outside the vehicle and you're on a job site or whatever, you can just pop it out of that and take it with you. So we provide products that give the best of both worlds.
Excellent. Well, thank you both for those responses. Really appreciate it. And to our attendees, unfortunately, we've run out of time today in our discussion. We thank you all for attending, and we'd appreciate you taking just a minute or two to share your feedback via our survey. A big thank you goes out to our awesome presenters today, Julianne Baker and Ty Estes, and of course, everyone from our sponsor, Hytera. This ends today's Safety and Health Magazine webcast. Take care, everyone, and have a safe day.